Okay, here we are, lesson 1-3, properties of numbers. Interesting and a little bit unusual lesson. Here we go. So this is one of those lessons that starts out with just a ton of vocabulary words in it. And so we'll go through some of these and see what they all mean. And these are on pages 16 and 17 in your book. And I will also put this video on Google Classroom if you want to go back to it for some strange reason. Who knows? Reflexive basically means A equals itself. Symmetric means that if A equals B, then B equals A. This is different than, like, some of the later ones, like the commutative property, because then you're actually talking about doing it with operations like addition and multiplication. So we'll get to those too. Transitive, this is one of those things, like people will say, if A is equal to B and B is equal to C, then A is equal to C. So that's transitive. Transfers from one to another. Substitution. Substitution is a really helpful one because if A does equal B, then anywhere you find B, you can put A in there. We use that a lot. It's very nice. Additive identity is saying A plus 0 equals A. That's how do you get the same thing in addition. You just add 0. 0 added to anything does nothing. Just A equals A, basically. Additive inverse. This one is how do you get what happens if you do the opposite. So if I have A and I add the opposite, negative A, you get 0. Now, compare those to multiplicative identity. That's where you have A times 1. To get A, of course, multiplicative property of 0, anything times 0 is 0. And the multiplicative inverse, that is the multiplying by the opposite. So A times 1 over A. This is also like the reciprocal. And we do that a lot because then if you multiply by the reciprocal, you get 1. So there's that part so far. And we have this quick review of commutative and associative. Remember, both of these only work with addition and multiplication. And commutative is usually the more useful one, or seems like even associative sometimes ends up being like commutative. Commutative, of course, A plus B plus C is the same as A plus C plus B. Any order, as long as all you're doing is adding, does not change the answer. Associative would be, for addition or multiplication, either one. And you can add B plus C first. You can add A plus B first. Same thing here. You can multiply A plus B, A times B, or B times C, or even A times C. So commutative and associative, it all works the same. There you go. Now what you're going to do is page 20 and 21, numbers 18 to 50 even. Oh, and I forgot 56. Okay, I want to show you what some of these look like. So here's your free answer of the day. Numbers 18 through 28 are going to be your least favorite part. And because it tells you to name the property used in each step. So here's what 18 would look like. 11 plus 7 plus 5 plus 13. And we've gone through some of these before where it's kind of like you're doing a proof. Because I can look at this and I can say 7 and 13, those work really well together to get 20. And then 11 plus 5 would be 16, so I'm pretty sure it's 36. And So the steps, though, there are a lot of ways you could do this. If you link back to the properties we just had, I look at this one and I see, okay, they want us to do some commutative stuff to move stuff around. But one of your favorite steps you're going to find is substitution, because you could just say, oh, 11 plus 7, I can do a substitution and put 18. And then I could add 5 more and get 23, and that's another substitution. And then I could add 13 and get 36, and that's another substitution. You can do this whole thing with substitution. It depends on, if you want to put more than one property in or not. It doesn't worry me too much. So what I'm going to say is I would rewrite it like this, and then do the commutative property. And then I'm going to do that, substitution, substitution, and substitution. Please do not write the whole words out. Abbreviate. Now, you have to do a little bit more abbreviating than just like putting, or a little less abbreviation. You can't just put C or S. But, this level of abbreviation is just fine. Same thing for the rest. I don't think you're going to have too much trouble with that. And there's really, as long as you get the right answer, there's really not a wrong way to do it. Like if you did substitution first and you added this for, it doesn't matter. The order doesn't matter. What matters is you get the right answer, and that you know why you're getting the right answer and the things you can do. Looking at 38 through 46, they show you something. You're supposed to actually figure out what x is, and then you're supposed to use, tell the property that they're using. And the properties they're looking at here are some of those beginning ones, like from pages 16 and 17. Should all be some of those things there. Other than that, we should be pretty good. Now I do want to look at 56. Let's go to a clean page and look at 56. 56 talks about closure property. And the book uses the explanation that the set of whole numbers, remember whole numbers starts at 0, 1, 2, ... goes on and on, that the set of whole numbers is closed for addition. What that means is if you add any two numbers that are whole numbers, you're going to get another whole number. So basically, since this goes on and on and on, there are no two numbers you could add in whole numbers to give you a number that's not also in this set. Like 0 plus 1 is 1, look, there it is. 1 plus 2 is 3. So there's nothing you can do to get a number that's not included in the set of whole numbers. For A, B, and C, they say, okay, so is it closed for subtraction, multiplication, and division? And for A, it says it's closed under subtraction. Now, if you think it's true, that means no matter what you subtract, you're always going to get the answer to be in the set too. If you think it's true, you just put true. If you think it's false, put false, but then give a counter example. So give an example that does not work. All right? Multiplication, same thing. For B, is it possible to multiply two whole numbers and get a number that's not in this set? And for C, is it possible to divide two numbers and not get a number that's in this set? So there you go. Make sure if it's false, you give a counterexample. If it's true, you just get to put true, because you wouldn't be able to list all of the possible true examples and eliminate them all. So there you go. That is it.